Good morning, fourth graders. Our learning target in math today is I can add and subtract fractions and mixed numbers with common denominators using a number line. So just like when we used models to add and subtract fractions and mixed numbers, the fractions and mixed numbers that we're going to be working with today are going to already have common denominators, so we won't need to find common denominators. But the difference between this lesson and the one I just mentioned is that today we're going to learn how to use number lines to add and subtract fractions and mixed numbers. And when we used models, obviously we learned to use models to add and subtract fractions and mixed numbers. In the last lesson, we learned how to identify and express fractions and mixed numbers on a number line. And it's really important that you understood that lesson in order to understand this lesson. So first of all, if you didn't complete watching that other lesson, the last lesson that I just mentioned, and doing the exit ticket for it, then you should do that before starting this lesson, because this lesson builds on the last lesson. So let's start with adding two fractions. So this problem is 2/5 plus 1/5. The denominator tells me we're going to have a whole broken into how many equal parts? That's right, 5 equal parts. And this time the whole is going to be on a number line. So I'm going to do what we did last time. I'm going to draw a number line with a whole broken into 5 equal parts. And here I have a number line with a whole broken into 5 equal parts. You can see 1, 2, 3, 4, 5 equal parts. There's the one whole. So we go from 0 to 1 whole. The whole is broken into 5 equal parts. When I'm looking at 2/5 plus 1/5, I know I'm going to want to start at 2/5 on the number line and then add another 1/5. But first we need to put the fractions on the number line. So we need to label each of those lines on the number line like we did last week. So before we even try to start 2/5 plus 1/5. So like I said, we needed to draw a number line with a whole broken into 5 equal parts. And we can see right here 1, 2, 3, 4, 5 equal parts in the whole. Here's one whole, 0 to 1 whole. Why don't you go ahead, I'm going to pause the video, or you pause the video, and go ahead and label the different places on the number line, if you remember from last week. And if not, go back and review last week's lesson. But go ahead and make sure you're able to label those, because you're going to be building your own number line just like this. So pause the video now and do that. And since the whole was broken into 5 equal parts, we should have had a denominator of 5 or fifths for each of the fractions that we place in the number line. And above the 0 increasing in value, we should have gone 1/5, 2/5, 3/5, 4/5. And the one whole was already there, which remember is kind of equivalent to, or is equivalent to 5/5. So the problem we started with was 2/5 plus 1/5. And so what we want to do is first we want to put a point, we call that to plot something, P-L-O-T, to plot 2/5 on the number line. When you plot something, you put a point there. So first, since we're starting with 2/5 and then we're going to add another 1/5, we're going to plot or put a point at 2/5 on the number line. And here I've done that. You can see the point at 2/5 on the number line. I plotted 2/5 on the number line. And then our problem says we want to add another 1/5. You see the plus sign. We want to add. When you add something, it increases in value. So we want our 2/5 to increase in value by another 1/5, or 1 part of a 5-part whole. And that arrow going from 2/5 to 3/5 shows 2/5 increasing by 1/5. 2/5 increasing by 1/5, going up in value by 1/5, which puts us at 3/5. So 2/5 plus 1/5, or 2/5 increasing by 1/5, equals 3/5. 2/5 plus 1/5 equals 3/5. One more time, 2/5 plus 1/5 equals 3/5. So next, let's try subtracting these two fractions using a number line. I notice that we're starting with 3/4, and then we're subtracting 2/4, or in other words, we're going to be going down in value by 2/4. And remember, on our number lines, when we're going up in value, when the value is increasing, we go up on the number line. And when we're going down in value, when the value is decreasing, we go down on the number line. So just like when we subtracted with models, we're going to start with the first number that we're given, which is 3/4. And one thing I notice about the 3/4 is the numerator is less than the denominator, so it's less than 1. And since we're starting with a fraction less than 1, and then we're going to be going down on that number line, I know that my number line is just going to need to show one whole, and then broken into how many parts? That's right, broken into 4 equal parts. So why don't you go ahead, even before I draw it, why don't you stop the video, pause the video, draw your number line reflecting one whole broken into 4 equal parts, and go ahead and label it. And then I'm going to do the same thing. So I'm going to pause it now. You pause it now, and then come back and see what it looks like, and see if you drew the same type of number line. So hopefully your number line looks like this. We knew we were starting with 3/4. We were going to be going down, so we just needed to draw a number line reflecting one whole. Since 3/4 and the number we're subtracting, 2/4, both have denominators of 4, the whole needed to be broken into 4 equal parts. So from between 0 and 1, we created 4 equal parts, and then we labeled above 0 the number line 1/4, 2/4, 3/4. And then I want you to see that this is the exact same thing. A lot of times you're used to seeing number lines that look like this. And this is also the exact same type of number line. It just goes from side to side. It's horizontal. But notice that it increases in value from left to right. So we have our 0, then 1/4, then 2/4 is greater than 1/4, then 3/4 is greater than 2/4, and 1 is greater than 3/4. And it just goes from left to right, but it's the same exact thing. And I'll actually show you how to do this one on both number lines. If you're more comfortable drawing a number line sideways, you can do that as long as you understand that it increases in value from left to right and decreases or goes down in value when we go from right to left. So from here, from 1 to 0, it would be going down in value. So the problem that we started with was 3/4 minus 2/4. So the first thing I'm going to do is I'm going to plot 3/4 on our number line. So that shows me that I'm starting with 3/4 on this number line. Along the same lines, that shows me I'm starting with 3/4 on this number line. And now we're subtracting 2/4. So that means we're going down in value or decreasing in value by 2/4. So notice on this number line, when we started with 3/4 and we decreased in value by 2/4, we decreased 1/4, 1/4 there, and another 1/4 there. So in other words, we decreased 1/4, 2/4, and we ended up with 1/4, which is the difference, or the answer, the difference in this problem. So 3/4 minus 2/4 equals 1/4. 3/4 minus 2/4 equals 1/4. 3/4 minus 2/4 equals 1/4. And notice again, when we subtracted the 2/4, we have two jumps there, 1/4 and then 2/4. And we end up with 1/4. So in our next problem, adding fractions, we have 4/5 plus 3/5. So first we want to create a number line. We know that 4/5 is less than 1, so and also we have denominators of 5 on both fractions, so we know that each whole is going to be broken into 5 equal parts. So my first step here is going to be to create a number line where I can plot or put the point for 4/5. So I'm going to want a whole broken into 5 equal parts on a number line. And go ahead and pause the video and try to create that number line. And then we're going to come back and you can see how we did it. So again, we want a number line with a whole broken into 5 equal parts. And we want to plot or put the point where 4/5 is and label the number line. Go ahead and try that. Pause the video. So when we create a number line with a whole broken into 5 equal parts and we plot 4/5, it should look like this. So from 0 to 1 whole, we have a whole broken into 5 equal parts. We labeled each part. We labeled 4/5. We're starting with 4/5, so we plotted our dot or our point at 4/5. The thing I notice is that we're increasing the plus sign, right? We're increasing its addition going up by 3/5. But on this number line, I can't go up by 3/5 just the way it's written, at least, even though that arrow up there means that it does keep going up in value even though we don't see it. So when we ran into that situation when we were using models, you can see 4/5 shown in the model below, and when we had to add another 3/5, we just created a second model, added the 3/5, and then you can see we got 1 and 2/5. With a number line, instead of creating a second model reflecting another whole, we're just going to add to the number line going up or increasing in value, reflecting another whole. So we're going to make this number line go to 2 wholes. And that second whole going from 1 whole to 2 wholes also has to be broken into 5 equal parts. And when I added to that number line, we still have our first whole broken into 5 equal parts. But now we have a second whole broken into 5 equal parts. So if you look from 1 to 2, we have 1, 1 and 1/5, 1 and 2/5, 1 and 3/5, 1 and 4/5, and then 2. And the only reason I changed colors when I was writing those mixed numbers on the left-hand side is because one has a finer point so that I could make those numbers more clear. So our original problem was 4/5 plus 3/5. We plotted 4/5 on our number line, and we're going to want to increase by that 3/5 or go up in value, which means we'll be going up on the number line. And 3/5 is going to be 3 jumps of 1/5 each. So 1 jump of 1/5, our second jump of 1/5, and our third jump of 1/5. So we've jumped 3/5 altogether, or increased 3/5 altogether from where we started at 4/5. Increased 3/5 after starting with 4/5. And we ended up at 1 and 2/5. So 4/5 plus 3/5 equals 1 and 2/5. 4/5 plus 3/5 equals 1 and 2/5. Okay, next we're going to add the two mixed numbers 1 and 3/4 plus 2 and 2/4. I noticed the denominator in the fraction part of each of those mixed numbers is 4, so that means that each of our wholes is going to be broken into how many equal parts? 4 equal parts. And we could draw a number line starting with 0, going to one whole, breaking that into 4 equal parts. We might be able to start somewhere else, because remember, number lines, those arrows at the end, the top and the bottom of the number line, mean that they just keep going forever. So we don't always have to start with 0. But why don't we go ahead and draw a number line starting with 0, see how far up you think you need to go. 0, 1, 2, how many holes we need to go up to. Why don't you go ahead and try it, pause the video, try that now, then we'll come back and compare it to what I've drawn. Go ahead, pause the video. So there I drew a number line starting with 0, between 0 and one hole. We got 0, 1/4, 2/4, 3/4, then 1. Between 1 and 2 holes, it goes 1, 1 1/4, 1 or you could say 1 1/4, 1 2/4, 1 3/4, 2. Between 2 and 3 holes, it goes 2, 2 1/4, 2 2/4, 2 3/4, and 3. I kind of ran out of room. I couldn't even get to 4 holes, so I got 3, 3 1/4, 3 2/4, 3 3/4. And I'll go ahead and see if I can solve this problem with as far as I got on the number line. Of course, the next number would have been 4 holes. But then I want to also think about how I could have, or how we could have drawn the number line differently to save time and space. It's one of the advantages of number lines, but first let's do this. So we're starting with 1 3/4, so we want to plot our point, or put our point at 1 3/4, and then we're going to add or go up from there. And the amount we're going up is 2 2/4, and so that's 2 holes and then another 2/4. So first let's look at what jumping 2 holes looks like and see if we can even fit where we want to go on the number line that we drew. So jumping 2 holes from 1 3/4 where we started, jumping the first hole takes us from 1 3/4 to 2 3/4. And jumping the second hole takes us from 2 3/4 to 3 3/4. And our problem is we jumped the 2 holes, but we still have to jump 2 more fourths. And we don't have anywhere on the number line we drew to go. We can't do that. So what really would have made sense is, since we knew we were starting at 1 3/4 or 1 and something more than that, we could have started our number line at 1 hole and then drawn it. So let's see what that looks like. So notice now, since I knew that I was starting at 1 3/4 and I was going to increase or go up by 2 2/4, I drew my number line starting with 1 hole instead of starting with 0. And that arrow going down means that, yeah, 3/4, 2/4, 1/4, and 0 were below that, but we just don't have to show it. And then I went ahead and I plotted the point at 1 3/4, which is where we're starting. Again, we're going to need to go up 2 holes and another 2/4 after that. So going from 1 3/4 plus 1 more hole gets us to 2 3/4. And then going from 2 3/4 plus 1 more hole gets us to 3 3/4. And then we still have to go up 2 more fourths, or 2 more parts of a hole. And there are those 2 little jumps of 1/4 each from 3 3/4. So we get to 4 and then 4 and 1/4. And so the sum of 1 3/4 plus 2 3/4 is 4 and 1/4. The sum of 1 3/4 plus 2 2/4 equals 4 and 1/4. So in this next problem, we're going to be subtracting mixed numbers. So we have 4 and 1/3 minus 1 2/3. And remember, when we're subtracting, we're starting with a number here, 4 and 1/3. And then we're going to be decreasing in value, or going down in value, which means going down on the number line by 1 2/3. So Look at how I started the number line. I started at the top with 4 1/3 because I know that I'm not going any higher than that. I'm actually going down on the number line. We're subtracting. The value is decreasing by 1 2/3, the number we're subtracting from 4 1/3. So you can see I went down 4 1/3, 4, 3 2/3, 3 1/3, 3, 2 2/3, 2 1/3, 2. And then I left the rest of the number line below that blank. I can start filling in it if I want, right? Under 2, I could put 1 2/3, 1 1/3, 1, and I could even go all the way down to 0 if I wanted. But I'm not going to do that unless I need it. I'm going to use the part that I need. So since we're starting at 4 1/3, and we're going down by 1 2/3, we're going to go down 1 whole from 4 1/3, the 1 whole and the 1 2/3. Because 1 2/3 means we have to go down 1 whole and then another 2/3. So when we go down from 4 1/3 by 1 whole, when we subtract 1 whole from it, it looks like that. We go from 4 1/3 to 3 1/3. And now we just have to subtract another 2/3, or go down another 2/3 or 2 parts on the number line. And this is what that looks like. So we went from 4 1/3, went down 1 whole to 3 1/3. You could see it there. Then we went down 2 more thirds. So from 3 1/3 to 3, and from 3 to 2 2/3. And that's where we ended up, because we subtracted the whole 1 2/3. So the difference between 4 1/3 and 1 2/3 is 2 2/3. The difference between 4 1/3 and 1 2/3 is 2 2/3. Another way of saying that is 4 1/3 minus 1 2/3 equals 2 2/3. 4 1/3 minus 1 2/3 equals 2 2/3. Okay, so we're going to move on to our practice problems. Remember, these are not your exit ticket. Your exit ticket will come later. For these problems, you're going to try each one, and then I'm going to come back and show you how to do them. So you're going to try them on your own first, and then you're going to check it against what I show you when I come back. So the first practice problem, 4/6 plus 5/6. And I noticed for that one that we're starting with a fraction. Think about how you want to create your number line, where you want to start, and experiment with that. But we know that it's we have denominators of 6, so our wholes are going to be broken into 6 equal parts. Then our second problem is 4 3/4 plus 1 3/4. And there I notice that I'm starting at 4 3/4, so I'm going to be going up 1 3/4 because we're adding, so the value's increasing. So I don't see why my number line would have to start at 0. That wouldn't make sense here because we're actually starting at 4 3/4. So maybe I'd start my number line at 4, or if it made sense to me at 4 3/4, I'll probably start mine at 4. And then the third problem is 6 1/5 minus 2 4/5. I didn't mention it for the last one, but we'll have our wholes broken into 5 equal parts for this one. And notice again here, we're starting at 6 1/5 at the top, right? We're going to start at the top of the number line, and we're going to go down. So it doesn't make sense to maybe draw a number line going from 0 at the bottom all the way up in fifths. Maybe it makes sense to start with 6 1/5 at the top and start going down, and we're going to be subtracting 2 4/5. So the third problem is 6 1/5 minus 2 4/5. Give it a shot, try it, and then we'll come back and I will go through each of those problems. All right, go ahead and pause your video, go back and look at the first practice problem, try it, second practice problem, try it, and third practice problem and try it. These are the three one more time. So for our first practice problem, 4, 6 plus 5, 6, I notice I'm starting with 4, 6, and in 4, 6, the numerator is less than the denominator. So I know it's going to be between 0 and 1. If I didn't, I can always start my number line at 0 anyway, but I started my number line at 0. Since the denominator was 6, if you look between 0 and 1 whole, we broke our whole into 6 equal parts. Then we labeled them going up from 0 to 1, 6 to 2, 6 to 3, 6 to 4, 6 to 5, 6 to 1. And we did the same thing. I did the same thing between 1 and 2. So 1, 1 and 1, 6, 1 and 2, 6, 1 and 3, 6, 1 and 4, 6, 1 and 5, 6, and 2. And we're starting at 4, 6 because we're adding, it's 4, 6 plus 5, 6. So I'm going to start at 4, 6. And then I'm going to jump 5 parts, right? 5, 6. Each of those parts is 1, 6. So I'm going to jump 5 times from 4, 6. And when I jumped 5 fractional units, or 5 sixths, when I jumped 5 times, I went from 4, 6 to 5, 6 to 1 whole to 1 and 1, 6 to 1 and 2, 6 to 1 and 3, 6. And then I plotted my point because that's the answer, right? That's the sum of 4, 6 plus 5, 6. Plotted my point at 1 and 3, 6 after I made those 5 jumps from 4, 6. So 4, 6 plus 5, 6 equals 1 and 3, 6. 4, 6 plus 5, 6 equals 1 and 3, 6. So for the second practice problem, of course we can always start our number line at 0 if we want, but since the problem is 4 and 3/4 plus 1 and 3/4, I figured I'd either start at 4 or 4 and 3/4, and then since it's addition, we're going up, I'd go up 1 and 3/4. So I'm going to start my number line at 4 just to be safe. Since we're adding 4 and 3/4 and 1 and 3/4 and the denominator is 4, I'm going to divide or break my whole into 4 equal parts. So you can see from 4 to 5, that one whole is broken into 4 equal parts. So as we go up our number line, I'm just going to go from 4 to 5 and 5 to 6 to give you an example. We go 4, 4 and 1/4, 4 and 2/4, 4 and 3/4, 5, 5 and 1/4, 5 and 2/4, 5 and 3/4, 6. And then I did the same thing going up to 7. So we're going to start at 4 and 3/4, and then I see that we're going to have to add 1 whole and 3 more fourths. So 1 whole and then 3 fractional parts. So I'll go ahead and start at 4 and 3/4 and make that jump of 1 whole to start with. And jumping 1 whole from 4 and 3/4 takes us to 5 and 3/4. And now all I have to do is, I've already started at 4 and 3/4. I added that whole, or I jumped up 1 whole. And now I have to jump up 3 more fourths, or 3 more of those fractional parts. 1/4 3 times. So again, I jumped that whole 1 from 4 and 3/4 to 5 and 3/4. Now I have to just jump those 3 more fourths from 5 and 3/4. So that takes us to 6, 6 and 1/4, 6 and 2/4, and 6 and 2/4 is going to be the sum there because we've jumped 1 and we've jumped 3 more fourths. We've jumped 1 from 4 and 3/4 to 5 and 3/4, and we've jumped 3 more fourths from 5 and 3/4 to 6 and 2/4. So 6 and 2/4 is the sum. 4 and 3/4 plus 1 and 3/4 equals 6 and 2/4. So for our third practice problem, 6 and 1/5 minus 2 and 4/5, just notice the denominator 5, so we know that each of our wholes will be broken into 5 equal parts. Since I know I'm starting with 6 and 1/5, and then I'm subtracting or going down, my top number on the top of the number line could be 6 and 1/5. I decided, since I know 6 1/5 is something more than 6, it's 6 plus a fractional unit, but it'd be less than 7, that I'd start with 7 at the top. So I decided to start with 3 holes at the bottom. Notice from 3 to 4, that's 1 hole. It's broken into 5 equal parts. And I decided to go all the way up to 7 on the top. So I built that number line going from bottom to top, from 3 to 7. So remember, for subtraction, we start with a number and then we take away from that number. Here on the number line, we're going to start at 6 1/5 at the top, and then we're going to subtract or jump down 2 holes, and then 4 more fifths, or 4 more units, because each of those little units is 1/5. So we're going to start at 6 1/5, and we're going to jump down 2 holes, and then we'll jump down 4 more fifths. So starting at 6 1/5, when we jump down 1 hole, we get to 5 1/5. And when we jump down a second hole, we get to 4 1/5. And then, like I said, we have to jump 4 more fifths down from 4 1/5. So when we do that, we go from 4 1/5 to 4 to 3 4/5 to 3 3/5 to 3 2/5. Notice those 1, 2, 3, 4 jumps. And then we get to the difference, or the answer here, which is 3 2/5. So 6 1/5 minus 2 4/5 equals 3 2/5. 6 1/5 minus 2 4/5 equals 3 2/5. I also want to show you another way we could have built the number line for solving the problem 6 1/5 minus 2 4/5. So remember, when we're subtracting like this, we're starting with a number. We're starting with 6 1/5, and then we're taking away 2 4/5. So on a number line, if we have 6 1/5 at the top, 6 1/5 at the top, we're never going to go above that, because subtraction means we're going down in value, and when you go down on the number line, you're going down in value. So I could write 6 1/5 at the top, and then the next number under that, since we're going down by fifths, because our holes are broken into 5 equal parts, which is what the denominator and the fraction part of the mixed numbers tells us, that we're going down by fifths. Our holes are broken into 5 equal parts. So we could go down from 6 1/5 to 6, and then figure out, like, to get from 6 holes to 5 holes, we need a hole broken into 5 equal parts, because the denominator is 5. So we could draw 5 more lines, and next to that 5th line that we draw, when we draw 5 more lines, we could put the whole number 5. So notice below the 6, I drew 1, 2, 3, 4, 5 more lines, and I put the whole number 5 next to the 5th line. And that it gives us a hole broken into 1, 2, 3, 4, 5 equal parts. So between 5 and 6, it gives us a hole broken into 5 equal parts. And now I can do the same thing to get from 5 holes to 4 holes. I can draw 5 more lines and put 4 holes, right? A 4 next to the 5th line. So 5 more lines going down, and put the whole number 4, because it goes 5, 4. If we go down to 3 holes, to 3. So now we're going from 5 holes to 4 holes. We're drawing 5 more lines. So I drew 1, 2, 3, 4, 5 more lines, put the whole number 4. And then I can draw 1, 2, 3, 4, 5 more lines and put the whole number 3. And later, if I needed, I could draw 5 more lines below 3 and put the whole number 2. But for now, remember that our holes are broken into 5 equal parts. Now I can go ahead and label the rest of those parts. So between 3 and 4, it'll be 3 1/5, 3 2/5, 3 3/5, 3 4/5, and then 4, and so on. So this is what that looks like. So starting with 3 wholes, we have 3 and 1/5, 3 and 2/5, 3 and 3/5, 3 and 4/5, 4, 4 and 1/5, 4 and 2/5, 4 and 3/5, 4 and 4/5, 5, 5 and 1/5, 5 and 2/5, 5 and 3/5, 5 and 4/5, 6, and then 6 and 1/5. And again, we don't need to go higher than 6 and 1/5 because we're subtracting down from 6 and 1/5. And again, I'll do the problem over again. So now that we have the number line written this way and we built it this way, we're subtracting 2 and 4/5. So we're subtracting 2 wholes and then 4 more parts, 4/5. So starting with 6 and 1/5, subtracting 2 wholes, which means jumping down 2 wholes, and then subtracting another 4/5, which means jumping down 4 more parts. So 6 and 1/5 minus that first whole is 5 and 1/5. 5 and 1/5 minus that second whole is 4 and 1/5. And 4 and 1/5 minus those 1, 2, 3, 4/5 is 3 and 2/5. So again, 6 and 1/5 minus 2 and 4/5 equals 3 and 2/5. Okay, now on to the best part, your exit ticket. Here are the instructions for your exit ticket. Make sure you follow them really carefully. So listen carefully, come back, review the instructions, make sure you're doing that for each problem in the exit ticket. The instructions, write each equation. This is an equation when you're adding or subtracting 2 numbers here, 4, 6, and 1, 6, and you have equal, the equal sign, and you have that answer here, the sum. So this is an equation. So that's the first part of the instruction. And you don't have to do it first. Obviously, you're not going to get the sum, the 5, 6, until the end, but that needs to be there. So write each equation, draw and label each number line, use the number line to solve the problem, and write your answer, which is the equation. So if we're starting with 4, 6 plus 1, 6, then you're supposed to draw and label the number line. So we did that. I did that from 0 to 1. I drew the number line and I labeled it. And then I used it to solve the problem 4, 6 plus 1, 6. So 4, 6, and then we just had to go up 1 part to 5, 6. So 4, 6 plus 1, 6 equals 5, 6. So I used the number line and I showed that work. And then I wrote the equation with the answer. So 4, 6 plus 1, 6 equals 5, 6. So make sure that when you work on your problems that you follow these instructions also. So for your exit ticket, here are your 5 exit ticket problems. Problem number 1, 2/5 plus 2/5. Problem number 2, 1 and 3/6 plus 1 and 2/6. Problem number 3, 4/5 minus 3/5. Problem number 4, 3 and 5/6 plus 1 and 4/6. Problem number 5, 5 and 1/4 minus 1 and 3/4. And that's it. So make sure you follow the instructions that we mentioned. Write each equation, draw and label each number line, use the number line to solve the problem, and write your answer, which is the equation at the end. Just like I showed you in the example a few minutes ago. So remember, our learning target today was I can add and subtract fractions and mixed numbers with common denominators using a number line.